Hello and welcome to another video on geology. In this video we'll be talking about resources. Well, what are resources? Resources are these objects which society needs to develop. For this course we categorize resources in three different things. Direct your attention to the middle of the board. We have minerals, which you know from previous lessons are solid or liquid compounds. Petroleum, which is a mixture of many different liquids and gases, namely petrol, aviation fluid, diesel, kerosene, and bitumen. Bitumen is this very solid-like liquid still. It's the stuff that they make roads out of, which you think is a solid, but actually it's a liquid. And lastly, coal. We separate that because coal, as you know, an organic sedimentary rock, is very important to our energy needs. So, how do we find these resources? Well, these are the steps we follow. Direct your attention to the left side of the board. Firstly, we need to find the resource we're looking for. We need to search for it, using many different techniques, which the next lesson will go into. And then we need to remove it, we mine it from the ground. Once we have that resource, it might not be concentrated enough to be of economic use, so we need to enrich it by concentrating enough of it to be of value, to be of use. And finally, once we have enough of it, we extract it, we separate it through chemical means. So this is a piece of hematite, which, if you guys remember the literacy task, this is iron oxide, just found mostly in the Pilbara. For the first step, we need to find this iron oxide in the ground. It could be magnetic, it could be many different ways of locating it. Then we need to dig it up. But we're not only digging up this is connected to other kinds of rock which we might not need. It's not just a pure mineral that you're digging up. And then the third step is to enrich it. We need to concentrate the iron oxide, eliminate all the other dirt and rubbish that we don't need. Finally, iron oxide, we only need the iron, we don't need the oxygen. So a chemical process takes place, removing the oxygen, and we have pure iron, which we can use to develop our society. So I use the word mineral to describe hematite. Going back to the middle of the board, hematite is a mineral. Minerals can be discovered in three different ways in their native form. So you're walking along the road or along the ground, and you notice there is a piece of metal in the ground. No, not because someone buried a piece of iron in the ground, but rather it was naturally formed through heat over millions of years. The ground, the earth, essentially completed the separation process for us. So you can actually find chunks of your resource just sitting there. That is called native elements. Then we have hydrothermal fluids. Well, as the name suggests, it's very hot, thermal, very hot. And again, you will get rocks with different veins of elements in them. The most common one is gold veins in certain kinds of rocks. I can't show you any because our school doesn't have any gold vein rocks. But essentially, when the temperature is high enough, you get melted gold that comes out of your ores, and it flows through different cracks of rocks and it kind of dries, cools down, solidifies, and you get these veins that go through certain rocks. Lastly, ores. Ores and minerals slightly are different. Ores have to be minerals of economic value, usually containing a metal that we need. I specify the word metal. It doesn't always have to be metal, but usually it is. And I stress the word economic. Yes, they are minerals, but they differ to normal minerals by the fact we need them to make money. Pause. The difference between minerals and rocks, you should remember, is that minerals are compounds, minerals are crystals, but rocks are just mixtures. So this is another reason why coal can be separated from valuable minerals. Because coal is just a mixture. Okay, so now we'll go into the properties of minerals. We have, direct your attention to the right of the board, hardness. That's Mohs scale of hardness, which is a relative scale. Luster, how shiny something appears to be. Color, basically the color, the appearance of it. Streak, when we get an unglazed tile and rub our mineral across it, what color does it produce? Flame, when we have a sample of mineral in a solution and we try to combust it, what color does it give off? Luster and color, the most obvious ones to do. The others all require some kind of equipment. Hematite. If you compare this, it doesn't have much luster. The color is grey. Very easy to do. This is pyrite. It's very, very shiny. Very high luster. It's yellow. Looks like gold. But no, it's not gold. It's fool's gold. This is actually iron sulfide. This is iron oxide. They're both actually iron. Very strange. They produce very different things. The streak of hematite is actually red. The streak of pyrite is actually black. Very strange. And I'm showing you this one because it looks very pretty. Galena, very shiny. And this streak is actually grey. So this is an example of the flame test, which you may have seen before. We've got a Bunsen burner with flame, and we've got just a solution of many different kinds of things. This is sodium chloride. It's reddish. Potassium chloride. It's purple. Sodium nitrate is yellow. Lithium chloride, it's red as well. Copper chloride is green. I hope this was helpful. See you guys next time.